What if I have a quiz on what my meeting is about? That is the silliest thing I've ever heard. So, no, one thing we did talk about in our meeting, and I'm serious about this. I should probably pause this video when I say this, but okay. So there's my little message too. Let's start this type of problem. Okay, for example 3, it says find the slope of the line tangent to the curve y equals 2x squared minus 3x at the point where x is equal to a. Yesterday we did a few example problems. We encountered a square root function. We also encountered another polynomial, and we also encountered a rational function. All of them have interesting ways of being solved. What I put together again on my notepad was a square root function that was also a rational function, just because I really want to see how the algebra will work out. Like I said, it was very lengthy, but it worked out just fine, and I was happy with the result. As we do problems like this, I would expect that basically everybody's capable of this on the test and a little bit more. Now this is different though. Notice how we always plugged a value for a in. It says find the slope of the line tangent here at the point where x is equal to a. Well, so it doesn't specify that value, and that's okay. That's actually going to allow us to use it more than once. Just think if you had to do this for every function at every point you were looking for. Well, instead of plugging in a every time, or that value for a, like 1 or 2 or 3, let's just plug in an arbitrary number, namely a, and let's see what happens. So, here's what it looks like. The limit as h approaches 0 of, so this is the slope, I'm trying to define it on this curve. What will I plug in for f of a plus h? Instead of actually plugging in a number, I just plug in a plus h. All right, normally we would plug in 1 plus h or 3 plus h or something like that. In this situation, we're just going to use a, so I'm going to plug in a plus h. I know that that looks strange, but I really think you're going to like the result, and this is more where we're moving towards in this course. So I have 2 times parentheses a plus h quantity squared minus 3 times a plus h. So I've just taken care of the first part, right? Now I need to minus my function with a substituted for x. So what will I have? 2a squared plus 3a when I distribute the subtraction sign. This is a common mistake, is did you distribute the subtraction sign or not? And in this situation I have. And all of that is over h. Okay. So I now need to work that algebra out. The limit as h approaches 0 of a plus h quantity squared will be a squared plus 2ah plus h squared. Very good. I multiply that all by 2. I have 2a squared plus 4ah plus 2h squared minus 3a minus 3h minus 2a squared plus 3a all over h. So right now I FOILed out the a plus h, I distributed the 2, I distributed the 3, and I wrote all my terms. Now, this is a very important part. We've learned that you should have a lot of cancellation, right? Name something that cancels. All right, my 2a squareds go away. My 3a's go away. And I will tell you guys right now, everything that does not have an h should cancel. Have you noticed that? If it doesn't have an h, it cancels. It should happen. Then everything that has an h will be able to delete one h, right? So this h will go away, this h will be reduced to 1, and this h will go away. So now I have the limit as h approaches 0 of, for a, Whoops, I forgot to cross the h off in the denominator. We knew that that would divide off. Plus 2h minus 3. And can I now plug in 0 for h? When you plug in 0 for h, what happens? The 2h goes away, right? Which equals 4a minus 3. So let me just write an expression here, or write a sentence, and please write this down. The slope at x equals a of f of x equals 2x squared minus 3x is equal to 4a minus 3. This is what we've said. So instead of our slope having a numerical value right now, it simply has a value that is dependent on what a is. This is wonderful, because instead of doing this for every point, I do it once. And now I can answer this question. Find the slope of the tangent lines at the points whose x-coordinates are 1, 4, and negative 3. So the slope is equal to 4a minus 3. So what's going to be the slope when the x-coordinate is 1? 4 times 1 minus 3 is 1. What's going to be the slope when x is 4? 16 minus 3 is 13. And when the slope is when the point is negative 3? So now that we've found this slope formula, if you will, we can use it for any point on that curve, as opposed to doing it every single time. Do you see the value in this? It's a good thing, isn't it? Graph the curve and the 3 tangent lines on the same screen. Let's do it. Let's real quick so we can speed this up. This side of the room right here. Okay, this side of the room. You guys come up with the equation for the line tangent at 1. Middle of the room, you guys come up with the equation for the line tangent at 4. And this side of the room, you guys come up with the line equation, or the equation for the line tangent at x equals negative 3. So quick come up with that, and then we'll put them on the board here, and then we'll check it on our calculator. So everybody's got to find an equation for one tangent line. Your middle. So find an equation for the tangent line. You have your slopes. You have your points. How do you find your y value? Plug it into the original function. Okay, there's some questions out here. So the middle group, let's just we'll get to the middle group in a second. Let's go to this side. Okay, so again, in order to write an equation for line, you need two things. You need m, and you need your point on your line. What is the slope? Negative 15. The point on the line has an x value of negative 3. How do I find my y value? I plug it in. So if you plug in negative 3 to your original function, negative 3 squared is 9, times 2 is 18, minus negative 9 is positive 27. So your point on your line is positive 27. So now you just need to go through y equals mx plus b. Y equals mx plus b. So 27 is equal to negative 15 times negative 3 plus b. Or 27 is equal to 45 plus b. Or negative 18 is equal to b. So y equals negative 15x minus 18 Yeah? Okay, so middle group, did you finally come up with one? What'd you got? Yes. Okay, so we're going to check to see if those three equations are correct. We're going to put them on our calculator. That way we can have a pretty good idea of whether or not we've done these. Okay, so we had 2x squared minus 3x. Oh. And then first group, what did we have? Y equals x minus 2? X minus 2? Middle group, we had 13x minus 32. And last group, we had negative 15x minus 18. So, if we just go zoom 6, zoom standard, you can see we have our parabola. Looks like that's tangent. Looks like that's tangent. Looks like that's tangent. If you don't like your view, then go ahead and change your window so you can go up to a Y maximum value of, say, 50. And if we try it again, we should be able to hopefully see, looks tangent, looks tangent, looks tangent. We've done our job. So again, we started out with a problem in calculus of what is the slope of a line tangent at a given point. We've been able to write 3 equations for lines that are tangent to that curve at given points very quickly. That's what we're trying to master at this point. From there, the possibilities are endless. You have time to work on your assignment that I posted for you yesterday, as well as I'm just going to add a problem similar to what we just worked on.